In this video, we'll look at solving exponential equations. There are a few different equations that we'll solve. Let's go through them now one by one. Question 1. 2 to the power of x plus 2 equals 1024. The first thing we need to do is rewrite 1024 as a power of 2. So we take our calculator and try different powers of 2, like 2 to the power of 5, too small. Okay, how about 2 to the power 8? Still too small. 2 to the power 9. Almost there. 2 to the power 10. Yeah, that's it. So what we have is 1024 can be written as 2 to the power of 10. Once you have the bases the same on both sides, with just one base, one exponent, one base, one exponent, you can drop the bases or set the exponents equal. In other words, if this is 2 to some exponent equals 2 to some exponent, they have to be equal. Since the bases are the same, it must be the case that x plus 2 equals 10. So we drop the base or set the exponents equal, and we get x plus 2 equals 10. Now it's a simple matter of just subtracting 2 both sides, and you get x equals, oh, almost made a mistake there, of 10 minus 2. What's 10? Take away 2. Of course, 8. Alright. On the second one, though, it's a little bit tricky because we might be thinking, well, let's get 128 base 4. But when you do that, 4 to the power of 3 equals 64, and 4 to the power of 4 equals 256. So let's do it instead by converting both to base 2. Hopefully you know without a calculator that you can change 4 to base 2 by making it 2 squared. So we get 2 squared for the 4, all to the power of x. And now let's convert 128 base 2. 2 to the power of 6? Too small. 2 to the power of 7, I bet. And that gives us 128. So we get 2 to the power of 7 representing the 128, and 2 squared representing the 4 with the x still on that. And we know when you have an exponent with another exponent on it, we multiply the exponents. So we get 2 to the power of 2x equals 2 to the power of 7. Now, since we have both bases the same, 2's on both sides, we can drop the bases or set the exponents equal, and we get 2x equals 7. Since 2x equals 7, all we have to do is get rid of what's in front of x by dividing, and we get x equals 7 over 2, or x equals 3.5. Our third question is a tricky one as well, because we want to get base 5, but there's this fraction here. But we'll start the same way. Let's figure out base 5. This says 5 to the power of 2x minus 1. This was 1 over 125, but we can make 125 into a power of 5. I'm pretty sure, but we'll check. What's 5 to the power of 3? 125. So this 125 can be written as 5 to the power of 3, still under the fraction. But on the next line, I'm going to bring it up by remembering that if it's put under the line, it must have originally been a negative exponent. The rule for negative exponent being flip under the line, change the exponent sign. So if it was 5 to the power of 3 under the line, that must have meant it was a negative 3 that got flipped under the line, changed the exponent sign. And once again, I'm at a good spot where I have two of the same bases with their exponents, and I just set the exponents equal. And I get 2x minus 1 equals negative 3. Now I want to get x by itself. Start by adding 1 to both sides, and you get 2x equals negative 2. The last move is just to divide by what's in front of x, in this case the 2, and we get x equals negative 1. The last question combines some of those skills. We want to get the bases the same, but we've got 27 and we'd like it in base 3. You might not even need your calculator, but you can just use it to check. 3 to the power of 3, sure enough, is 27. So we can rewrite 27 as 3 to the power of 3, and all that's to the power of x. Just rewrite the left-hand side. On the right-hand side, an exponent with an exponent on it, multiply the exponents. And once again, we're in a good situation where same base with an exponent on each, we can drop the base or just set the exponents equal. And now we're back to solving for x. How do we do that? Let's get these x's off of here, or combine the x's, or get the like terms on the same side by subtracting 3x both sides. And when we do that, 5x take away 3x just leaves 2x plus 8. On the right hand side, we get 0. 3x take away 3x. So now let's move this plus 8 over by subtracting 8 on both sides. And you get 2x equals negative 8. Last move, just like the last question, when you have 2x, divide by the coefficient, the number in front of x, and you get x is equal to negative 4. So those are a few different types of equations that involve exponentials that we can solve.